we had started off on a path of talking about where our piece is and where the rest of it is.
Yeah.
So we've got our piece that's, that foundry part, right? But to make all of that work, we need to have the whole ecosystem from collecting the debris or some other feedstock. If it's not debris, it could be, metal launched from Earth. It could be metal that comes from the moon. It could be metal that comes from asteroids. But in the beginning, it'll be, probably space debris.
Sure.
Somebody's got to go out and get that. That won't be us. We're not building the space trucks. Okay. Then it's either got to come to a place where we do the work. And that would be like, if you imagine like an industrial park where you have your recycling plant. So this is going to be space stations that other companies are already working on. Like, Nanoracks has an interesting concept that called Outposts that we've been looking at as a possible way to host this. But it could also be on, the upcoming what's it called, the Orbital Reef one that Blue Origin and Sierra Space are working on, amongst others. And then you've got Northrop Grumman that has one. There's a number of concepts out there. I mean, ranging in interesting, like conventional to exotic kind of ideas.
It's finally happening.
It's finally happening, and many of these are even the ones that seem kind of further out there, I think, are quite plausible, actually. But so all of these things could be hosting for our platform. They're the real estate.
Okay.
So we just want to buy space at these industrial parks to host our capability. They'll supply us with the power and the communications as part of the utilities that we buy from that commercial park. We'll pay the trucking companies to bring it to us, and probably to deliver the goods if they need to go to another platform or something.
Yeah.
The other configuration that we talk about is where, imagine you have a debris removal spacecraft, and it just needs to remove debris. It doesn't need to do anything with it. We could put the Space Foundry on there, and it could make propellant for that piece of that spacecraft that enables it to remove propellant as a limitation from the calculation. So instead of getting 5 missions or 4 and needing to find a depot to refuel at, it basically can refuel itself as it goes. And if you're just trying to remove debris and deorbit it, that could be an interesting configuration as well. And there's some other applications for this sort of configuration that are possible.
Yeah.
But actually, it makes me realize we haven't really talked about the propellant part of this yet.
I was about to bring us to that. So yeah. So one question I've got in my mind, and this will be a transition into that. From one perspective, this is a vulnerable position to be in for CisLunar Industries. You're one piece of a value chain, and the other 12 or whatever, none of them are actually working and up and running, or very few of them are. Yet. How is that a strength?
Yeah, I mean, the way I look at that is, if you look at modern economies on Earth, which is where they all are right now, you don't have these monoliths that own the entire, production chain like Ford did back in, in the beginning of the Industrial Revolution, right? A diverse economy makes it more robust. So yes, in the sense of having a risk that we aren't building our own platform, we aren't building our own space trucks, we are reliant upon partners to do that work for us.
Sure.
I believe that a bunch of these companies are already working on it. They're already investing in it. That means we don't have to invest in that technology also, which means we can all get there faster. And by us being in the middle of this picture, we make the work that the debris removal companies are doing that much more valuable, because now that waste that they're trying to get rid of has a market value as a commodity, which changes the value proposition for them. It creates a use case for the platforms, right? It feeds materials in to build those platforms with and extend them, grow them, make them bigger, do different things with it, right? And then all these things together just create a much more robust, dynamic economic system that's driven by having, just the normal economic incentives that we've seen our economy grow with so far on Earth. Applying the same thing to space means that there should be diversity. And many companies in every vertical, probably including metal processing for that matter, that will help to make this robust system happen, which means that even if one of our partners doesn't make it, there'll be another one that we can use, right? It's not going to be like a one-stop shop.
That's fair. And yeah, I mean, we even see that in the space industry, right? The SLS launch system, space launch system, just finally rolled on out into the pad. It looks really pretty. It's a really expensive piece of hardware
Yeah.
that you can only use once. There's some benefits to it, but it is a little frustrating that it can't be reused. But that's because it's on the old model.
Yeah.
Right? It's been 20 years.
The government run model. Basically.
Right.
Yeah.
Or if you compare that to what NASA has been moving more towards, which is, hey, we'll be first customer. We'll do grants and stuff. Then all of a sudden you see the difference between SpaceX and ULA, where they said, hey, we wanted you guys to develop a human-rated system to get astronauts up to the ISS.
Right.
Two different competitors. ULA just crapped the bed twice. Weren't able to do it. They're still working on it. Maybe they've fixed their software.
To be fair, I think it was Boeing actually that had the problem, not ULA, because the rockets that launched that capsule worked fine.
Okay, I did misspeak that. Yep. Fair. Yeah, because that's where the distinction is.
Boeing does own ULA, so they're all kind of mixed together. But
yeah. but to that point, there was multiple providers.
Right.
And so we haven't had to pay Russia.
Right. Which is pretty critical right now.
It's pretty important.
Yeah.
So good.